Hi guys, let's do problem number 5 on page 3, which is the hockey puck colliding with the wall. So question 5 addresses momentum in 2 dimensions. A student shoots a 2-kilogram hockey puck with an initial velocity of 10 meters per second and it hits the wall at an angle of 30 degrees and bounces off. The puck leaves the wall with a final velocity of 10 meters per second. If it takes a total of 0.02 seconds to complete the collision, what was the average force applied to the wall by the hockey puck? We're assuming no energy is lost during this collision. And the hint was to make a table of all the given variables. Be careful because momentum is a vector. Okay, so remember that in kinematics, once we saw that there were 2 dimensions to our kinematics, x and y, we could never simply just combine them and work with a vector that was not on the x or y axes. And the same is true for momentum in 2 dimensions. So we need to resolve our velocity vector and take a look at momentum in the x and momentum in the y. So the vertical component of our incoming velocity, VIY, is going to be equal to 10 meters per second times sine of 30, and that's equal to 5 meters per second. Now if you look at the angle at which the puck makes when it comes off of the wall, it's another 30-degree angle. So our VFY is also 10 meters per second times sine 30, or 5 meters per second. Now I'm going to make up positive and to the right positive. So both of these are positive 5 meters per second. Okay, now let's look at the horizontal or the x component. So for our incoming velocity, VIX, we get 10 cosine 30 degrees, and that's positive, or 8.67 meters per second. But for our outcoming velocity, VF, we have negative 8.67. So again, this is 10 cosine 30 degrees, but it's pointing the opposite direction as the initial velocity. So it's negative 8.67 meters per second. Okay, and that, again, that's 10 cosine 30 degrees. Okay, so here we have our velocity vector resolved. So remember what we do once we resolve our vectors is we squiggly line through it to remind ourselves that we have resolved this vector into its components. And then the hint that I gave you was for you to make a table of all the given variables and being careful of the sign. Okay, so let's start with the mass since that was easy and given. We have mass equals 2 kilograms. We have a VIY equal to 5 meters per second. We have a VIX equal to 8.67 meters per second. We have a VFY of 5 meters per second. And we have a VFX equal to negative 8.67 meters per second. The delta T was given to us, and that was 0.02 seconds, and the average force is what we're solving for. Okay, so let's go ahead and solve for the force, and in order to solve for the average force, we need to solve for the x component of the average force and the y component of the average force. And once we get those 2 components, those will be the legs of our right triangle, and we can square both sides to find the resultant vector. So what I mean by this is once we solve for the force in the y direction, the force in the x direction, remember, in order to add our vectors, Oh, apologies, that didn't work as planned. In order to add our vectors, we go tail to head. Okay, so Fy should be over there. Then I can draw my hypotenuse here. This makes a right triangle, and this would be total average force. So using Pythagorean theorem, Fx squared plus Fy squared equals F squared. So let's solve for our force in the x and the y direction. So we start with, again, writing out the entire equation. So F delta t equals m delta v. I'm solving for force, so divide both sides by delta t. And the equation that I'm going to use then is F equals m delta v over delta t. If we break this apart even further, that equals m vf minus vi over delta t. So let's take a look at average force in the x direction. So that is going to equal our 2 kilograms, because mass does not change. Our VFX, so VFX is negative 8.67 meters per second. And VIX is positive 8.67 meters per second. So we get 2 kilograms times a negative 8.67 minus 2 kilograms times a positive 8.67 all over delta t. So for our numerator, we get a quantity of negative 34.68. And the units of that is kilogram meters per second, and then in the denominator 0.02 seconds, and that equals negative 1734 newtons. Okay, so this is the force in the x direction, the average force in the x direction. Now let's look at average force in the y direction. So again, writing out the full equation, F sub y is going to equal m times VFY minus VIY over delta t. Plugging in our values, we get 2 kilograms. VFY is 5 meters per second. Minus, and VIY is positive 5 meters per second, all over 0.02 seconds. Now 5 minus 5 is 0, so our entire numerator is 0. So it doesn't matter what our denominator is. Fy equals 0. So that means that all of the force is in the x direction, and there is no force in the y direction. So we don't even have to go through the steps of using Pythagorean theorem in order to find the total average force, because there only is total average force in the x direction, and that quantity is equal to negative 1,734 newtons. All right, guys, hope that made sense. If you have any questions, please come in and we can chat about it. Bye.